In this video, we're going to discuss about root locus. Before understanding root locus, let us see what is locus means. Locus is nothing but a line or curve formed by points satisfying certain condition. Whenever we want to form a line, series of points are required. That means whenever we want to make a line or a curve, the moment of the points are required, then only it is possible to make line or curve. Well, let us take one simple transfer function which has second order system, that is tf is equal to k divided by s square plus as plus k. Well, the stability of such system depends on the location of the poles. As you know already, if the poles are left hand side of the S-plane, then the system is stable. If poles are on imaginary axis, then system is marginally stable. If poles are on right hand side of the S-plane, then system is unstable. Sometimes what happens, the parameter, the gain k changes. If it changes, then poles will move from one place to another place in the S-plane. So due to the moment of this pole, the stability may be changes. So therefore, to understand the locus of the system, here what we'll do, we'll changes gain k from minus infinity to plus infinity. Then we'll see how the pole's movement. Based on this, we can say that how the system is stable or unstable. So therefore, the root locus means the locus of the closed loop poles obtained when system gain k is varied from minus infinity to plus infinity is called root locus. Well, we'll understand this root locus concepts very clearly by considering the same transfer function here. The characteristic equation of the given transfer function is s square plus as plus k is equal to 0. The roots of this characteristic equation will be calculated by using Sridhar's formula, where s1 s2 is equal to minus a divided by 2 plus or minus square root of a divided by 2 square minus k. Well, as you know that here we're going to obtain the root locus from minus infinity to plus infinity. Here I consider the various instances here, that is k is equal to 0 on the k timeline, then k is equal to a square by 4, and the third one is the range from a square divided by 4 to infinity. Well, let us consider the when k value is equal to 0, instead of minus infinity to infinity, for the simplicity I am consider only these three instances. Well, when k is equal to 0, then s1 value is equal to 0, s2 value is equal to minus a. For the second instant, when k is equal to a square divided by 4, then the roots of s1 and s2 both are equal, that is minus a divided by 2. Let us consider the third instant, that is range from a square divided by 4 to infinity. In this situation, what happens? The roots are become complex conjugate, which has real part minus a divided by 2. Let us put all these variations on the S-plane now. Here the k is, we're assuming that from minus infinity to plus infinity, but for the simplicity purpose I am consider the three instant as k is equal to 0, k is equal to a square by 4, and from a square by 4 to infinity, and these are the roots as you know already. But one important thing we have to observe here, when k is equal to 0, s1 value is equal to 0 and s2 value is equal to minus a. Let us put these points on the S-plane now. So here I will say this is S1, its value is 0, and let us say this is S2, its value is minus A. These two terms are obtained when k is equal to 0. If k value is increased from 0 to a square by 4, we can see that the S1 value increases from 0 to minus a by 2, and S2 value decreases from minus a to minus a by 2. Well, let us look at that on the S plane what happens. Now as k value is increases, see that S2 value decreases. Let us say here this is minus a divided by 2, and S1 value increases from 0 to minus a by 2. Further, if I increase the k value from a square by 4 to, then the roots are complex conjugate with the real parts. That means now the poles will leave this the real axis, then it moves like this in the upward direction, and another one pole is moves in downward direction, but we cannot predict that right now whether which one is this is upward direction or downward direction. But let us assume that out of these two, one is moving in upward direction and another one is moving in downward direction. Okay, so now the pole is moving from 0 to upward direction, minus a to downward direction. So this is happening due to the change of parameter from 0 to infinity. This is what we can call that the root locus of the given second order system. Now we'll check existence of root locus. For this I will consider the general transfer function, that is 1 plus g of s into h of s is equal to 0. I will take this 1 to left hand, so okay. Now we'll check the existence of root locus. For this I will consider the transfer function 1 plus g of s into h of s. I will take this 1 to right hand side, so therefore it's become minus 1. Here imaginary part is 0, that is indicated by plus j is equal to 0. This is exactly a Cartesian form. Now we'll convert this Cartesian form to polar form. In the polar form it consists of two parts. One is magnitude, another one is angle. So this is what we can call that polar form. And here from these two conditions, so the one of the condition is very helpful for to checking the existence of the root locus, that is called angle condition. If the angle condition is satisfied, so what mean by that angle condition is satisfied means if the angle of this entire value is odd multiple of 180, then we can say that the given pole is exist on the root locus. Again I'm repeating, if the angle value of this thing is odd multiple of 180, then the pole is exist on the root locus. We'll see this by using one of the very simple problem here. So in this problem what they're saying that we have to check that the s value s is equal to minus 0.75 exist on the root locus or not for a given transfer function. Then so for this what I do, I'll substitute s value is equal to minus 0.75u in the above equation. Then the angle condition of this is g of s into h of s is equal to, here the gain parameter k is constant, no need to do anything with this value right now. I have to substitute s value is angle condition of minus 0.75. From the second term substitute s value, that is minus 0.75u plus 2, and third term is the angle condition of this into minus 0.75 plus 4. Okay, now we'll find the angle of this. The angle of gain constant, K is constant, divided by minus 0.75. The angle of this one is 180 degree into the angle of this one is 0. Angle of third term, this term is also 0. So now I'm going to bring this term from denominator to numerator. Then this is minus 180 degree. As you know already, if the angle condition of the given transfer function is odd multiple of 180, then we can say that the given pole is exist on the root locus. Okay, if the angle is not equal to 180 or odd multiple of 180, then what we can say that the given pole is not exist on the root locus. Thank you.